orange box on the top of page 142 has our order of operations. We'll be using those rules today as we work through some of these problems. And what you know about order of operations is the first thing we're always going to do is what's inside the parentheses. Step 2, we're going to handle all exponents. Step 3, we're going to multiply or divide in order from left to right. And step 4, we're going to add or subtract in order from left to right. Okay, so if you take an extra second to make sure you've got those down, it's going to be extremely important for us today. There's going to be a lot of information that's going to be thrown your way, but none of it is new. Yes, ma'am? 142. It's on page 142. So I'm going to just kind of keep going here. Order of operations is a standalone lesson when you're just using integers, just using your regular counting numbers. It's an entirely different thing altogether when we start incorporating fractions into the order of operations, because fractions have certain rules that we have to follow based on the operation that's being performed. So let's review that. Okay, star number 1. To add or subtract with fractions, what do we need? What is needed when we add or subtract fractions? Common denominators. When we add or subtract with fractions, we need common denominators. That being said, to multiply or divide fractions, we need fraction form with the little asterisk. Remember, division, we flip, or we call that multiply by reciprocal. Okay, so take a minute and get that down, because it's going to be. Let's take a look at our first example. 3/4 plus 1/8 minus 3/10. So first one we're going to try today. Now, order of operations tells us that as I look at it, as I go from left to right, the operations that are present in this problem are addition and subtraction, which isn't rule number 1, not rule number 2, not rule number 3, but which rule? 4, which tells us that we add and subtract in order from left to right. So we can just take this as it is. what is it that is needed if I'm going to add or and subtract these fractions? Yes, Alexis. Common denominators. Very good. So we have the option is we can try to get them all to have common denominators right now and do that first. If that's the case, when I look at a 4, an 8, and a 10, which one is my biggest denominator? 10. So let's start thinking of our multiples of 10 and see what will also work for 8 and 4. So 10 won't work, 20 won't work. Takayla, does 30 work? How about 40? 40 does. So let's convert them all to 40ths. Convert them all to 40ths. So 3/4 becomes how many 40ths? Carlos? 30. 1/8 becomes how many 40ths? 5. And 3/10 becomes how many 40ths? What's up? Sure. How many here? Times 4 is 12. Okay, now we've seen it written like this. We wrote it vertically. If we establish the fact that 40 is going to be our common denominator, this is going to work out the same way. Casimir, when I look at my denominator, how it changed from 4 to 40, I must have multiplied the 4 by, so then the top gets multiplied by 10, and we get 30. When I look at how 8 moved to 40, I multiplied by 5. So then 1 times 5 must be 5. And then 10 times what? So then 3 times 4 is 12. Are we better now? All right. It's nothing new. So now, we are going to add 30/40ths and 5/40ths to get what? 35/40ths. And then we are going to subtract 12/40ths, and we get? Carlos.
Like say you have like your denominators are like 4, 8, and 12. Could you divide the 12 to make a 4? Divide the 8 to make a 4 too?
Sometimes. But what's the thing about division that makes it different than multiplication? Can you divide any numbers that you want? No. So it only depended if it would work with the numerators. If it was 12, then you probably have to use 24 as your common denominator. Okay? All right. So you could keep it horizontal if you understand it, and you just want to rewrite it that way, that's fine. Or if you want to do it the way we did it here, it's fine too. Okay? But you know, this is stuff that shouldn't be like, huh? I mean, we've done this already. 3 1/4 times 3/8 plus 1/2. Okay. So a little bit different than our previous problem. However, once we take a step back, and that's what I'm going to encourage you to do, is write out the problem and then just take a step back and look at it and make sure you know what you're doing. Have a plan. Things are always better when you have a plan. So when I look at order of operations and I look at my first step, it says to take care of all operations within parentheses first. Do I have Any parentheses in this problem? Yeah, so obviously the first thing I absolutely have to do is what? Right, I've got to add 3/8 and half. And in order to do that, what is it that I need to have, Desi? Which is what between an 8 and a 2? All right, let's just pause there for a second and give everyone a chance to get to where they need to be. Okay, order of operations told us we had to do the parentheses first, so that's what we're doing. 3/8 will stay as is. 1/2 goes to how many eighths? 4. So now, that's 7. Now, is 7/8 our final answer? No, 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 no. Now what needs to be done with the 7/8? I need to multiply it by 3 1/4. Okay? So, that brings us to multiplication. I don't need common denominators when I multiply. They need to be in, not simplest form, fraction form. So let's get that 3 1/4 to fraction form. Yes, it's going to make it improper. 3 times 4 is 12 plus 1. So 13 over 4 times 7 over 8. Are we flipping anything?
No.
No, because I'm just multiplying. You only flip when you divide. So 13 and 8. 4 and 7. No. So we're not too lucky here. 13 times 7 is 91. 4 times 8, 32. Okay, now what?
Since the denominator is smaller than the top,
91 divided by 32. How many times can I fit 32 into 91? 2 times is 64. So let's take away 64 from the 91. And I should get 27 over 32 in simplest form. And that is our final answer. Now, if you get here, folks, and you're stuck because the numbers are too big for you, you just get psyched out easily, then absolutely, Maya, you can set it up this way and try to find out how many times does 32 go into 91. And as you start going through your numbers, you're going to say, oh yeah, 2 is going to give me 64. Then when you do your subtraction and you get 27, you're going to find out that you have the 27 left over with your 32. Okay, so that's if you get stuck and you can't figure it out in your head and you have to take that extra step and write it out, then by all means write it out. Okay? So that's what we're looking at, problems that are going to be like that. So that's what I mean, you got to be on your toes and you've got to be really paying attention to what's going on. So here's one for you to try. Go ahead. Order of operations says, what has to be done first, the multiplication or the subtraction? In order to do the multiplication, they need to be in fraction form. Now, 3 over 4 is in fraction form, and what do we mean by fraction form? That I have one number on top, one number on the bottom. So I need to get the 1 1/6 to have that. Because it's a mixed number, it's going to be an improper fraction. So 1 times 6, 6 plus 1 over 6. So let's do this first. Because whatever I get here, I will then subtract 1/8 from. But we have to wait on this part. So now, anything in common with a 3 and a 6? There's 1 there, there's 2 there. So 1 times 7, 7 and 8. So now I have 7/8 minus 1/8, which is,
Yes.
okay? So really, what are these problems, really, they're having you do at least 2 problems within the one. So we did this one, where we got the 3/4 times the 7/6, and we got 7/8. Then from there, we took the 7/8 and subtracted 1/8 and got the 6/8. So we did 2 problems in one. Okay? And that's just kind of the way the steps take you. But there shouldn't be the point, 6th graders, that you look at these and you say, I have no idea what I'm doing, I have no idea where to start. We have added and subtracted with fractions. We've also multiplied and divided them. We've done everything they're going to ask us to do. It's just a matter of putting them all together. Okay, let me put it this way. Okay, let's put it this way. This will simplify it for you. At one point or another, you all learned how to walk. My son he's been walking for a couple of weeks, you know, and he walks around like this with his arms up like Frankenstein, right? He's getting it. And the more space he has, the further he'll walk. There will be one day when he will also learn how to chew gum. Okay? And then hopefully, he'll be able to do both of them at the same time. He'll be able to walk while he chews gum. 2 skills put together. You've learned the skills of adding and subtracting. You've also learned the skills of multiplying and dividing. So now you too will have to put them together. Just like walking and chewing gum at the same time.
Which is dangerous.
Right. So, you know, I don't know, you call it multitasking now or whatever it is we decide to call it now in the 21st century or wherever we are. It's our excuse for saying we're too busy for things. Sierra. You didn't reduce. So then when you got to this point, Sierra, you had to put it into common denominators, right? So you made more work for yourself. This step here, you guys, and I've told you this 1,000 times, doing this, you all want shortcuts. You all want to figure out what the shortcut is in math, and then I show you one, and you don't want to take it. Okay? Yes. We'll do another one. Look at that. Positive Casby. I don't know if they're going to give us exponents today, Alexis. There you go. All right, order of operations. Does order of operations say we're going to add or multiply first? Multiply. So here is what we're going to multiply. 2/5 times what is the 8.5 in fraction form? Okay, any shortcuts I can be taking here? Set 17/5 is equal to what? Okay, are we done? No, now we got to go back to the beginning and say, this 3 2/5 I need to add to my half, right? So what is the common denominator between a 2 and a 5? 10. So times 5 is 5, times 2 is 4. 5 plus 4? There it is. Yes? Yeah, I mean, I've got a choice here, right? Watch. I've got this whole problem. So I either add 1/2 and 2/5, or I multiply 2/5 and 8.5. So it's either I do this or I do this, depending on which one I should do first. Can I what? You have it as the order of operations. Did you look at your order of operations first and say I need to multiply first?
Yeah.
Well, then you should have multiplied.
So the number that's main tool you multiply by.
Well, yeah, I mean, how else do you multiply numbers?
Okay.
You're going to take this number way over here and multiply it by something when there's a plus sign in between? Don't make it harder than it is, right? Just take it for what it is. All right, where are we at time? Oh, man. How are we supposed to squeeze a homework assignment out of this?
Please don't squeeze my homework. Don't.
Ease. There you go. Because we did what with it? If we had to get common denominators, we were doing what? Either adding or subtracting. When I multiply, what's the rule? Fraction form. So let's take the 5/9. Let's just go in order. Times the 2/7. Okay. Equals 10 over 63. Now we're going to multiply it to the 9/10. Now here's where that shortcut comes into play. 10 and 10. How about 9 and 63? They have 9 in common, right? And there happens to be 7 of them there. 1 times 1. 7 times 1. 7. Let's do all that just to get 1/7. What if we decided to do this? Because I'm looking ahead. I'm coming up with a plan, and I'm thinking about what the best option is. And I look and I say, I'm going to pick the 5/9, and I'm going to multiply it to the 9/10 first, because when I look at 5/9 and 9/10, they have things diagonally that I can reduce. They have a 5 and a 10, and they have a 9 and a 9, which is going to give me half. I multiply that half times what's left, and I say 2 and 2, I still get the 1/7. And I took it out of order, but because I was just multiplying, that's okay as long as I do what I'm supposed to do the way I'm supposed to do it. So, sometimes math is very rigid. It'll say you have to do this in this order. And then sometimes you have options like we do here. Your job is to try to determine when you have options and when you don't. Okay? So that's what makes math a little bit challenging at times. In the time we have remaining, which is 2 minutes, is not enough. I'm not confident enough that we all have a good handle on this, so there's no redo for tomorrow. There's no assignment. You have absolutely nothing for tomorrow.